Now, you did graphing systems, or you did graphing inequalities before, and now you're going to be doing graphing a system of inequalities. So now we're going to have to do some shading. Now, if you look at this, the solution of the system of inequalities is the part that's overlapping on their shading. So you might want to use either different colors or something like that to make it easier. So first things first, I need to solve for y. So I'm going to get negative 2y is greater than negative x minus 6. Y is less than, 1/2 x plus 3. So I'm going to go, and it's dotted. So I'm going to go up to 3. 1, 2, 3. Up 1 over 2. Up 1 over 2. Down 1 over 2. Down 1 over 2. Now the shading on this. Okay, if I use the point 0, 0, is 0 minus 0 greater than negative 6? Yes, 0 is greater than negative 6. So this part is shaded. Then do my other one. Use red. I have a open dot here. My slope is 3. 1, 2, 3 over 1. 1, 2, 3 over 1. Okay, if I was to put in 0, 0, is 0 less than 0? Oh, well, we can't do that. It lies on the line, so we have to pick a different point, remember? So we have to pick, I don't know, let's pick 1, 1. So 1 is less than 3 times 1. So 1 is less than 3. Is that true? Yes, it is true. So that means that this side is what is shaded. Okay. So guys, I just want the part that overlaps. I don't want all the rest. So you either have to do it super duper shading, or you need to get rid of the part that is not. So this part right, oops, I didn't mean to do that. I meant to have a highlighter. This is the part that overlaps. Okay, so let's come over this one. Let's solve for y. Oh, we've already solved for y. It's just on the wrong side. So y is greater than 1/3 x plus 2. I switch my inequality. I put them on opposite sides. So this is 2. 1/3, so up 1 over 3. 1 over 3. Down 1 over 3. Down 1 over 3. Okay, test point. So if I use 0, 0, is 0 plus 2 less than 0? Is 2 less than 0? No, it is not. So that means that I have to do the opposite side. So we're doing this side. Then, this one right here. Y, that says x, not y. So x is negative 3. So that's a solid line. And it's the numbers greater than negative 3. So that means this. But I want the part where they overlap. So the part where they overlap is the part that I want. So I'm wanting this section up here. I don't need this, and I don't need this. This part right here is the part that's the solution. I'm going to have to do this strategic. I'm going to take this and bring it down here. So this is going to be 4y is greater than 3x. Divide and get 3/4 x. I don't know why it did that. So I have an open dot at 0, 0. I go up 3, 1, 2, 3, 2, 3, 4. I go down 3, 1, 2, 3, 1, 2, 3, 4. Okay, if I plugged in 0, 0. Oh, I can't do 0, 0. It's at 0, 0. So I'm going to do, just to be careful, I'm actually going to test this point right here. So -1, -1. So if I plugged in -1, -1, it would be 3 times -1 plus 4 times -1. Is that greater than 0? So that's 3 minus 4. Is that greater than 0? -1 is not greater than 0. That is a false statement. So that means that we have this down here. Okay, so let's do the other one. So if I subtract 3x to the other side, I get -4y greater than or equal to -3x plus 8. Divide everything by -4. And I get y is less than or equal to 3/4 x minus 2. Notice how that they're going to be parallel lines because they have the same slope. So I go down to -2 and I go up 3, 1, 2, 3 over 1, 2, 3, 4. I go down 3, 1, 2, 3 and over 4. They are going to be parallel lines. Okay, and we have to figure out the shading on this one. So if I did, I'll even use the same test point. Try to plug it back into the original, or to the other one. So I'm going to test -4, -1, greater than or equal to 8. So that's -3 plus 4. Is that going to be greater than or 1? Is that greater than or equal to? No, it's not. So that means that when I shade this, I want below. So I need the parts that are overlapping. And if I do the overlapping part, that's down here. So I need to get rid of the other parts. So that's the part that's overlapping. Now, if you have pencils, if you're doing pencils, then you do them super light on each one. And then the part that is the actual answer, either highlight that part, use a color, I don't care. So we did it again on this one. Oh, this one's cool. This one right here, all we have to do is switch it around. That's nice. Y is greater than x plus 3. That one's easy. So I go to 3, 1, 2, 3, open dot, go up 1 over 1, up 1. This one's easy peasy lemon squeezy. Plug in 0, 0, because it doesn't go through 0, 0. 0 plus 3, is that less than 0? That is a false statement. So when I do this, I will be shading above that line. Let's do my second one. So if I subtract 3x to the, oops, I'm using a highlighter. Subtract 3x to the other side, -3y greater than or equal to -3x plus 12. Divide by -3, -3, -3. I get y is less than or equal to x minus 4. So I go down to -4. 1, 2, 3, 4. Is that closed or open? Closed dot. Guys, and do you notice that I go all the way through the graph? I don't just stop in the middle. There are some of you that are stopping like right here. Nope, it needs to go all the way across the graph. So now if I plug in 0, 0 to this, so 0 minus 0, is that greater than or equal to 12? Nope, that's a false statement. So it's not going to contain 0, 0. Highlighter. Ooh. Right here. So what's the answer to this? The answer to this is no solution. There is no place where they intersect.